we're going to be taking a look at solving polynomial equations. So if we take a look at this example, the solutions of the equation 64x cubed plus 152x squared minus 62x minus 105 equals 0 are negative 5 halves, negative 3/4, and 7/8. So those are the x-intercepts. Now we want to notice here is that the numerators 5, 3, and 7 are factors of the constant, the negative 105. The constant term, negative 105. And notice that the denominators, 2, 4, and 8, are factors of the leading coefficient. The leading coefficient of 64. So these observations are generalized by the rational root theorem. So if you have f of x equals a sub n x to the n plus ... a sub 1 x to the first plus a sub naught, it has integer coefficients. Now, integer coefficients are whole numbers, but they also include like negative numbers as well as the 0. So it says that every rational solution of f of x equals 0 has the following form. So normally you would see P over Q. P is the factor of the constant term. The constant term, which is the a sub 0, or a naught, over the factor of the leading coefficient. Factor of the leading coefficient of a sub n. Now another way to remember this, instead of P and Q, because we have used P and Q before, is B over F instead. B over F. B, I would say, stands for the back, okay, the back, which is your constant, over the front, which is the leading coefficient. I can remember B and F because that makes sense to me. The back is the constant. Front, well, that's the leading coefficient. And maybe that might help you in memorizing it. So let's take an example. We want to be able to solve this following polynomial. We have x cubed minus 8x squared plus 11x plus 20. The first thing you want to do is be able to see, can we factor this in ways that we know how? Now, first we're like, okay, let's look at factoring by grouping. But you look at it a little closer, this is 11 and 20. So 11 doesn't divide into 20. And then again, we won't be able to get something from the first term. So currently, this is not factorable. So we have to turn to another method. Factorable. And so what we want to do is use what's called the rational root theorem. We want to find the possible solutions that this polynomial has. So let's think about back over front. So the back is our constant over the leading coefficient, and our leading coefficient is 1. So the first thing is take a look at what are the factors of 20. And write them in order, that's helpful. So 1, 2, 4, 5, 10, and 20. And then 1 is just 1. So the possible roots that we could try for this polynomial equation is plus or minus 1, this 1, over the denominator 1, plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 5 over 1, plus or minus 10 over 1, and plus or minus 20 over 1. So any of these could be a solution to this equation. So while it doesn't seem like that it narrowed it down, because we have 1, 2, 3, 4, 5, 6, 6 times 2 is 12 different possible solutions, we actually narrowed it down. So for example, you wouldn't want to try 3 because 3 is not a factor of 20, right? So you would never try 3. So let's just start. We want to use synthetic division in order to evaluate to see if it is a possible, if it is a solution. So we test solutions using synthetic division, and if it results in a 0, then it is a solution. We're not missing any terms, so it's 1, -8, 11, and 20. So let's test positive 1 first. So bring down the 1. 1 times 1 is 1. -8 plus 1 is -7. 1 times -7 is -7. And this is 4. 4 times 1 is 4. And this is 24. So that is not a solution. So let's try -1. 1, -8, positive 11, oh, just 11, and then positive 20. So this is 1, -1, -9, positive 9. 11 plus 9 is 20. 20 times -1 is -20, so therefore this is 0. So this is great. So -1 is a factor. Now that is x equals -1. So remember how to write it as a factor? That is x plus 1. Then, let me make some room. X plus 1. And then we have to write the quotient here, our answer to the, after synthetic division. So this is the remainder. This is x0, x1, x squared. So this is x squared minus 9x plus 20. And then we see if we can factor it further. Yes, this is factorable. So x plus 1, and this is x squared, oh, not x squared, x minus 4 times x minus 5 equals 0, right? We're trying to solve. So x equals -1, 4, and positive 5. These are the solutions of this polynomial equation. Again, we do this because we want to be able to eventually graph it all. So these give us our x-intercepts. Just to review it, x-intercept is -1, -1, and then also at 4 and 5, there's nothing repeated. We think about the end behavior. This is an odd degree polynomial. It's 3. Leading coefficient is positive, so that means the ends go in opposite direction. We also know the y-intercept is at 20. So we know it goes up forever on the right, so it passes through the 5, passes the 4, then eventually it passes through the y-intercept of 20, and then comes back down through the 1, and then returns to down forever. So that is eventually what we're getting at. Now go ahead and try the second example.